Statistics and probability are math concepts that are used every day in real life. Our world today revolves around data. You need to learn how to use that data so you can make important decisions. Statistics is the study of data. You are going to be studying data collected on what you ate for 5 days, and then learn to sort, analyze, and make predictions based on that data. So the 4 things you're going to be doing in this exercise are collecting data, sorting data, analyzing data, and determining basic probability. 1. Collecting data. The first task is to collect the data. You can't do anything without a survey. What you survey can be as broad as the data Google collects to as simple as how many times your dog will catch a ball, which in my case is pretty often. Bird surveys are done in many communities around the world, and the information from them help to track the rise and fall of bird species in an area. And the computer usage of teenagers helps give information about trends, and I'm sure that technology companies use the data to plan what they create and sell back to teenagers. So data is necessary. You got to have the data first. Sounds simple, right? Just collect data. But wait, there is more. If companies and scientists are going to use data for important purposes, then the data sampling needs to be valid. That means there has to be enough data from the population so that the information is relatively accurate. Look at this simple example. Do you think asking 4 friends about what flavor milk they like means that chocolate milk is more popular and therefore the school should order 75% of chocolate and only 25% of white milk? This sample was too small, but it's not easy to ask everyone either. So you want to find enough people to get data from, like maybe your whole class or your grade in this instance, but probably not going to be able to ask everybody, say every student. Now that you've collected your data, you need to do something with it. So you need to sort data. This is the second piece. The first step is to create a chart that shows you visually the relationships in your data. When you look at the charts here, the bar chart and the line chart, you see a huge spike in the middle and then some up and down areas. That would tell you that one part of your data was really different from the others. But that might not be so easy if you were just looking at the raw numbers. Depends on your data. 3. Analyze your data. Now it's getting interesting. Let's go deeper and look at the data you collect. There are terms that are collectively called statistical landmarks. Look at the list of terms in red here. Minimum, maximum, range, mean, mode, and median. These are all ways of analyzing the data you collect so you can start to see meaning in it. And as you can read here, minimum is the smallest value in your data, maximum is the largest, the range is the difference between those two, the mean is if you added everything up, you could also call this your average and divided it by the number of values. The mode is different in that it's the number that occurs the most in your data set. And the median is the number in the middle. So if you lined them all up from left to right, and you counted from the one side and you counted from the other, the median would be the number in the middle. Let's take a look at this, because those terms, that doesn't matter. That doesn't mean too much so far. Okay? Remember that bar and line graph you saw? Well, this is the data it was plotting. This data is a survey of how many books one class read over the summer. Look at that number on the second row to the left, 60. Right here. That was the peak you saw in the data. This student read a lot more than others. Now let's look closer at the data. Look at the mean for a moment. What effect do you think that 60 books had on this? In this example, there are a lot of students who read between 10 and 13 books, so the 60 books doesn't change the data as much as it could if there was only about 5 examples and 60 was one of them. Probability. Okay, now let's take it one more step further. You have your data and you've charted it. and you've gotten some statistical landmarks to help you get meaning from the data. So what is probability? Data doesn't just help us figure out what happened in the past. It can be used to predict what might happen. This is where data really becomes useful. Years of data on weather help meteorologists predict how much rain or snow we are likely to get, and information on election night helps predict who will win before all the data is counted. Data is everywhere, and understanding how to use it will be important in your life. So the terms you want to make, you're looking at is likely, unlikely, certain, and impossible. Let's take a look at that. Let's use the weather, for example. It's always easy to use weather. If the weatherman says that you've got an 80% chance it's going to rain really hard on Saturday, do you think it's unlikely or likely that your soccer game will be canceled? Well, if I was going about this, I'd probably say it's likely my game is going to be canceled because they said it's going to rain really hard, and 80% is pretty high, right? But are you certain? Well, you can't really be certain, right? There's a 20% chance that it won't happen. So what's certain? Well, I think you can be pretty safe to say that it's certain the sun will rise. And it's probably impossible that you're going to grow to be 10 feet tall. Okay, so math is cool, it's useful, it's fun, it's necessary, and it's important to you. And that's why math matters. Thank you, and have fun on this project.